dear students. Myself, Dr. Ashwini. Today we are going to discuss the basics of units and dimensions. So why we require units? What's the requirement of these dimensions? What is this unit actually basically for? For that, let me consider an example. So you're going for a grocery shop. You're asking for sugar. How are you going to ask the sugar? How are you going to buy the sugar? You're going to ask, give me 1 kg of sugar. If someone asks, what is your height? You're going to tell, I am 5 feet 2 inches height. If someone asks, what is your weight? You may tell, I am 50 kg weight. If someone asks, what is the time now? You will tell, it is 10:30 a.m. So here you are using different numerical values. You are representing all these parameters with different units. That means the quantities which are measurable, which can be expressed in terms of numerical values, we are going to call them as the physical quantities. And we require the units to represent the quantities. As just now we mentioned, the mass is expressed in terms of kg. The time is mentioned in terms of seconds or in hours. The weight is expressed in terms of kg. Length is expressed in terms of minutes, like this. So today we are going to understand the fundamentals of these units and dimensions. So here the contents of our presentation will be having this. Just we will introduce about the introduction, what is the unit, what's the system of units that is adopted internationally, the fundamental quantities and their basic SI units, the supplementary quantities, abbreviations for multiples, submultiples, some important conversions, some physical constants and their values. So basically, as I mentioned, so any quantity which can be measured directly or indirectly in terms of the numerical values, we are going to call it as a physical quantity. So there are two types of physical quantities are there. The first one is the fundamental quantity. See, fundamental quantity means which cannot be expressed in terms of any other physical quantities. These fundamental quantities are independent. They can be expressed independently. For example, mass is expressed in terms of kg. Temperature is expressed in terms of Kelvin. Time is expressed in terms of seconds. Length is expressed in terms of meter. So these are the various physical quantities which are expressed independently. If I consider the area of a square, area is expressed in terms of meter square. So for area, I am using the unit of the length, that is meter. So here area is expressed as meter square. If I consider density, density is kg per meter cube. So here I am using the kg, which is the fundamental unit for mass, meter cube, meter, which is the fundamental unit of the length. That means the derived quantities, the physical quantities which are derived from the fundamental quantities, or what we are going to call it as the derived quantities. So actually there are two types of physical quantities. The first one is the fundamental quantities, the physical quantities which cannot be expressed in terms of any other physical quantities, that is they are independently expressed. They are called as fundamental physical quantities. So example, length, mass, time, temperature, we can list 7 fundamental units, what we are going to discuss in the next slides. So derived quantities, so physical quantities which are derived from fundamental quantities, or what we are going to call as derived quantities. So example, area, density, force, etc. So let us now know about this unit. What is the unit what we are going to use to express a physical quantity? So as we just mentioned, kg, mass, it is 5 kg of sugar or 50 kg of your body weight. Time is some 10 hours, 30 seconds. So here we are representing unit. We are using a unit which gives a reference for this physical quantities, which is standard reference. Okay, if someone asks like how much you love your mother, so what is the hatredness, what's the sweetness, what is the attitude, can you measure these quantities? No, these quantities can't be measured. I can't measure how much I love my daughter. I can't measure how much I hate some upma. I can't measure what is the attitude of that particular student. So here there are physical quantities which can be measured, as just now we mentioned, they are the physical quantities, and the quantities which can be measured, which can be expressed in terms of some standard of reference, we are going to call it as a unit. So unit of measurement of physical quantities is a standard reference of the same physical quantities which is used for comparison of the given physical quantity. So fundamental units, in the units we are having two types of units, the fundamental units. So as I mentioned, next slide we are going to discuss which are the fundamental units. So the unit which is used to measure the fundamental quantity is what we are going to call as fundamental unit. So derived unit means the unit which is used to measure the derived quantity is what we are going to call as the derived unit. So for example, for fundamental unit, the meter for length, kg for mass, Kelvin for temperature, second for time, ampere for current. Like this, there are 7 fundamental units. We will discuss that in the next class. Derived unit. The unit, as I mentioned, example area. So here we are having meter square, gram per centimeter cube for density, meter per second for velocity, meter per second square for acceleration. So these are the derived units. So derived units are the units which are derived from the fundamental units, which can be expressed in terms of fundamental units. Now we are having various system of units which are adopted to measure the physical quantities. The first accepted system was the FPS system. So FPS stands for foot, pound and second. So length is measured in terms of foot, mass is expressed in terms of pound and time is expressed in terms of seconds. The second system was the CGS system. In the CGS system, the length is measured in terms of centimeter, mass is expressed in terms of grams and time is expressed in terms of seconds. The third system was the MKS system. So in the MKS system, the length is measured in terms of meter. The mass is expressed in terms of kilogram and the time is expressed in terms of seconds. Now, the universally accepted one is the fourth system, what we are going to call it as the SI system. So SI system, the word SI stands for the International Standard of Units, which is abbreviated as SI. So based on this SI system, the internationally accepted universal standard of system, there are 3 categories of physical quantities. The first one is the fundamental quantities. Remember, in the fundamental quantities, we'll be having the fundamental units. The quantities are expressed in terms of these units, what we are going to call them as the fundamental units. The second one is the supplementary quantities. There are 2 supplementary quantities which we'll see later. The last one is the derived quantities which are derived from the fundamental units. So let's first look for this fundamental quantities and their SI units. So as I mentioned, there are 7 fundamental quantities and 2 supplementary quantities. Remember, the fundamental quantities are the one which can be expressed independently. They will be the standard ones. Okay, the 7 fundamental quantities are length, mass, time, thermodynamic temperature, luminous intensity, electric current and the amount of substance. So length is expressed in terms of what? The length is expressed in terms of meter. So representation, the symbol is small letter m. Mass is expressed in terms of kilogram. So its symbol is kg, small k, small g. Time is expressed in terms of seconds, small letter s. Thermodynamic temperature is expressed in terms of Kelvin, capital K. Luminous intensity is expressed in terms of candela. So symbol is capital letter C, small d, CD. Electric current is expressed in terms of amperes, symbol is capital letter E. The amount of substance is expressed in terms of mole and the unit is symbol is mole, MOL. So these are the 7 physical quantities and the corresponding SI units and the corresponding symbols. Students, remember one thing. So these are the 7 basic fundamental units we should remember, because whatever we are going to discuss later will be purely depending on these physical quantities, on these 7 fundamental units. Okay. So next what we are having is the supplementary quantities. There are 2 supplementary units. The first one is the plane angle, the physical quantity, plane angle. The second quantity is the solid angle. So plane angle is expressed in terms of radians. The unit is rad, R-A-D, expressed as rad. The solid angle is expressed in terms of steradian. The unit is steradian. The symbol is SI. So these are the 2 supplementary quantities what it is universally accepted. Okay. So let us consider the basics now. The basics, how the length is expressed, the mass is expressed how, the time is expressed how. Let us consider the first one, the measurement of length. Remember, now I'm telling, I'm like, if someone asks, what is your height? You may tell like, I'm 4 feet height, 2 inches. You're using different representation, feet, inches. If someone asks, what's the distance between Tumkur and Bangalore? You're mentioning as 70 kilometers. You're using the word kilometer. If someone asks, what is the radius of an atom? You will tell, it is Fermi. It is 10 power minus 15 meter. So here we are using different parameters, different units to express the same parameter, that's the length. Okay, so length of an object can be measured by using different units. So here we are having a list of some basic units of length. The first one is the angstrom. So angstrom is given by 10 power minus 10 meter, which is equivalent to 10 power minus 8 centimeter. Centi means how much? 10 power minus 2. So 10 power minus 8 into 10 power minus 2 becomes 10 power minus 10 meter. Nanometer, nano is 10 power minus 9, that is 10 angstrom. So Fermi, it is 10 power minus 15 meter. Micron, micron is 10 power minus 6. Micrometer is 10 power minus 6 meter. The X-ray unit, what we are going to measure, it is 10 power minus 13 meter. One astronomical unit. See, astronomical unit is the one which is the unit which is used to measure the distance between Sun and Earth. It is equal to 1.496 into 10 power 11 meter. And remember, there is one more unit which is standardly accepted one. It is the light year. So what actually light year is? See, light year is a distance travelled by light in 1 year. And light year is the unit which is used to measure the distance between the various astronomical objects. The distance between Earth and the Mars. The distance between the various astronomical objects like Sun and Moon. The Sun and the Saturn. The distance between the various galaxies. So light year is the one which is standardly used one. Okay, so 1 light year is equal to 9.46 into 10 power 15 meter. So how we will get this value, we'll discuss in detail when we enter the chapter of units. Okay, so parsec, 1 parsec is 3.26 light years. That is 30. If you multiply 3.26 into 9.4 into 10 power 15, you're going to get as 30.84 into 10 power 15 meters. Bohr radius, it is 0.5 into 10 power minus 10 meter. And 1 mile, it is equal to 1.6 kilometers. So these are the various length units what we are going to use, the various different units for length. Thank you.